Alright guys, so based on the valence shell electron pair repulsion theory simulation that you did yesterday, which uses that PhET simulation that I'm showing right there, we should be able to give a good try to making a Lewis structure for this and then determining its shape and all those kinds of things. Alright, so the first thing of course you have to do is you need to count the total valence electrons. So we've got a sulfur and we've got two bromines. So back to the periodic table, and once again we're looking for sulfur. You're looking for the small group number 6. You're looking for bromine. You're looking for the small group number 7 valence electrons. So that means that we've got 6 valence electrons for sulfur plus 2 times 7 for bromine. 14 plus 6 is 20 valence electrons. Now, there is only one sulfur but 2 bromines, so I'm going to put the sulfur in the middle. I'm going to join the bromines with a single bond. And then I'm going to choose either bromine, doesn't matter. I'm going to start, fill it completely up, and go all the way around. Remember, we start at a terminal atom. It doesn't matter which one you do, but you do need to start at one of them. Now, I've got four total electrons shown right now. That's 6, that's 8, 10, 12, 14, 16, 18, 20. All right, now, quick check. First for octets. 2, 4, 6, 8, check. 2, 4, 6, 8, check. 2, 4, 6, 8, check. Now for total number, it's 20. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Those are equal, check. That is a good structure. Now, number of bond locations. All right, so number of bond locations, I'm going to color green. So number of bond locations, I got one bond location there and one bond location there. So I have a total of 2 bond locations. Number of lone pairs, I've got 1, 2, 3, 4, 5. Oh, I'm sorry. I apologize. What am I thinking? Lone pairs around the central atom, because that's all that counts on valence shell electron pair repulsions. Apologies. So I'm only looking at this guy here. All right. Lone pairs, number of lone pairs. 1, 2. So I've got 2 pairs of lone pairs around the central atom. Electron domains is going to be the number of bond locations plus the number of lone pairs for electron domains. Now, another way of thinking about that is just simply how many things are hanging off of the central atom. So this is the central atom. It's got 2 bonds. It's got 2 lone pairs. That is 4 electron domains. Now, 4 electron domains gives me a molecular shape of, gives me an electron shape of tetrahedral. But that is not the molecular shape, because remember, if you have lone pairs, it causes your molecular shape to be different. So let's go back to the simulation and have a look. So what did we have? We had 2 bonds and 2 lone pairs. So we're going to do that on the simulation. All right, 2 bonds, 2 lone pairs. All right, that is my molecule right there. Now I'm going to put it into the same configuration that I'm going to draw it in. All right, so I think right about there. Perfect. All right. Now, notice that I've got electron geometry of tetrahedral, but my molecular geometry is bent. And my bond angles, it shows me, is about 109.5. Now, that's not strictly speaking true, but we're going to go with it at the moment. Okay, so molecular shape is going to be bent. Estimated bond angle, 109.5. Now, in reality, each of those lone pairs takes up more space than a bond. So that 109.5 is going to be smaller than that 109.5. It's going to be less than that. So if we look at a real molecule, like say water, which is exactly the same kind of structure. See how that's exactly the same idea? Electron geometry is tetrahedral, molecular is bent. Show the bond angles. 104.5. You subtract approximately 2 degrees per lone pair. So in reality, it's really 104.5. In reality, or about 105. Now, drawing a 3D molecule. The 3D drawings are always the same. If you have 4 electron domains, all you do is you put in the central atom, and then you put in the line, the wedge that's coming out at you, and the dash that's going back in. Now, notice that is exactly the same as that, right? You got the line at the top, you got the line to the side, you got the 2 lone pairs, one coming out at you, one going back away from you. Then you go ahead and you put in your lone pairs and your atoms. So the easiest thing to do is to put the bromines on the lines, right? Just like they are in the drawing or on the simulation. Then you can put the lone pairs on the wedge dash. And don't forget to add in all your lone pairs. So each bromine's got an additional 3 lone pairs. And then there's a lone pair there and a lone pair there. So here we go. That bromine is right there. This bromine is right there. One of the lone pairs is the one coming out at you, and the other lone pair is the one going away from you. And so it looks just exactly like that.